All right, so we just got through spending 2 days doing these things without a calculator. Today, we are going to solve them with a calculator. Now, keep in mind, all right, it may say exact answer and it may say approximate. Okay, the approximate answer, that's always going to be the decimal. All right, and we're going to talk about how to find both of these. Okay, and if you do get a decimal, you round to the thousandth, which is 3 decimal places. Okay, that's pretty standard in calculus, so that's what we do in pre-calculus. Okay, so first off, looking at part A, we are going to use our calculator, but I want you to think about what do we know about how to rewrite exponentials. How can I rewrite this a different way? Log, right? And we'd start with the base of the exponent. So we'd put 5, log base 5, switch to the other side, 9, so like the drop, cross, and that should equal x. And that's what we're trying to find, is x, right? Okay, this right here, this is my exact answer. Is there another way that I could rewrite this log? Maybe using change of base formula? Yep, log of 9 over log of 5. And this, you don't have to rewrite it. I'm just kind of doing this so that I can get our approximate answer. All right, so now we're going to use our calculator here. All right, we are going to do log of 9. Make sure you close parentheses, by the way, or behind that 9, and then divided by log of 5. That's how you use change of base. You could use ln instead of log, but that's how you're going to get the approximate answer. That's how you do log base 5 of 9. You do log of 9 divided by log of 5. All right? So let's write that down. Let's round to 3 places. Okay, I'm going to show you one other way to get the approximate answer that some of you are going to like more. All right, so watch this. We already know what that number is. If we go into y equals, you can solve any equation you want. And what I'm doing is I'm going back to the very original problem. This is kind of like the shortcut way. Those of you that really don't like doing any work, you're going to love this. Okay, we're going to do 5 caret x. Okay, and then what do you think we're going to put in y2? 9. Right. y1 equals y2. And you've done this before. We've done it in here and you've done it in other classes. We want to see where these two things intersect. It wouldn't be bad to just start off doing a zoom 6. Now we may need to change the window, or we may need to zoom out or something, but sometimes you luck out and you can see the intersection right off the bat. All right, do you guys remember how to find intersection? Second trace, number 5, and then what? Enter, enter, enter. Okay, is that the same decimal we wrote? 1.365. Which way do you like better? The way I did it the first time or this graphing way? This is a personal preference, so whatever. All right, here's the deal. If the directions say you have to come up with the exact answer, you have to be able to do something to come up with that answer. So I'm not trying to just get you to do extra work for no reason. All right, there are 2 answers here, exact and approximate. If the directions only say approximate, then you can do the whole y1, y2 intersection. All right, so let's look at B. All right, and let's do the exact answer first. So again, we're going to rewrite this as a log. All right, so we would do log base E of 7. Okay, drop the base to the base of the log, cross to 7, and that equals 3x. Is there another way we can write log base E? Yeah, ln, natural log. This would be a better way to write it, and this is how we're going to do this in our calculator. So x is almost by itself. What do I need to do algebraically? Divide by 3 so that the 3's cancel. Okay, so my exact answer is natural log of 7 divided by 3. That right there is the exact answer. That's what you would have to do if the direction said find the exact answer. Okay, if we want the approximate answer, which I didn't show this on example A, but hold on. All of a sudden, give me a second. Okay, so we can say that this is approximately natural log of 7. Make sure you close the parenthesis behind the 7, divided by 3, and you get 0.649. This right here is my approximate answer. What's the other way I could have gotten the approximate answer? In the very beginning, if it didn't even say exact, if all it wanted was the approximate answer, I could have just done y1, y2, found the intersection. All right, I'm not going to show that on every single problem, but okay, so now let's look at C. Okay, so this starts off as a log, so we're going to write it as an exponent. It's just like whatever you're given, try writing it the other way, and that's how you're going to solve for x. So ln is log base e. You still have to know that. So you're going to do e to the power of the right side, and that equals the log argument, which is x. So it's always start with the base of the exponent of the log, and then you just switch sides. So that already is my exact answer, because x is already by itself. My approximate answer, I would just plug in the calculator. Do you remember how to find e on the calculator? Excuse me. You see the ln button? If you do second ln, it does e to the power of, and then you would just do -1/2. If you do not have the updated system, by the way, some of you might not, you might need to do parentheses here. Okay, so that all of that's in the power. I think most of you do have the updated system though. Okay, 0.607. Okay, what do you guys think about D? What should we do? Maybe to the right side. Yeah, condense it. To be a single natural log, and what would I do with the numbers 4 and 6? Would I add them or multiply them? Multiply them. The log property says if you have a log plus a log, it's a single log with the product or multiplying. Do you need a calculator to do this next part? No, it's just 24. Okay? That's all. That's all you got. You don't even need to write approximate because 24 is the exact and we don't even need the decimal. Okay, so some of these on this calculator part, you really don't even need a calculator to do. You still could, though, do the whole y1, y2, find the intersection. You would get 24. You'd have to zoom out a little bit, though, on that one. Okay, so on the back, you can notice they're a little bit more complicated. So definitely these, you may want to do the whole y1, y2 intersection thing to check your work. All right, algebraically, just treat this thing right here as if it were just like x. Okay, if that had said 2x minus 2 equals 4, what would be the first thing you do? Add 2, so that it would cancel with that 2. And whatever you do to one side, you do to the other. And so that right side would be 6. And then again, if this e to the power of, if that had just been an x, what would you do next? Divide it by 2. Okay, now we have something like how we had on the front. We have something that's an exponential form. It's simplified as much as we can go. So what we need to do next is rewrite this as a log. Okay, remember, you're going to write log. You're going to write the base of the exponent as the base of the log. Cross to the other side, and that equals your exponent. Okay, log base e. What's that the same as? ln, natural log. And then how do you get x by itself here? Multiply by multiply by 3. Now, watch real careful here because I don't want anybody to get this wrong. If this is 3 natural log 3, it doesn't become natural log 9. Okay, you could use a property to move that 3 over, but it wouldn't be 3 times 3. It would be 3 to the 3 power. But that's unnecessary. We've gotten x by itself. We have our exact answer. Okay, to get our approximate answer, we're going to go 3. We're going to hit the natural log button, 3, close parentheses, enter. 3.296. And that is our approximate answer. Okay, again, we could have done y1 and y2 to also get the approximate answer. On your test, you're going to have some of these on the calculator part where all you have to do is find the approximate answer. If you wanted to do the whole y1, y2, that wouldn't be a bad way to do this. It'd get you out of a lot of algebra here. So that's something you might want to practice. Okay, what about f? Ideas? Okay, if this plus 3 had not been here, don't scratch this out on your paper, just watch me here. If this plus 3 had not been here, it is there, we'll have to deal with it. What would we do with these two logs? We'd condense them to single log. Okay, so, but the 3 is there. So what I really want next to the 3 is log of something. And you want this thing to be equal to 1. Because can't you multiply anything you want times 1? And it doesn't change it. Okay, so log of what equals 1?
0.
If you flip that around, it's true. Log of 1 is 0, but log of 0 is not 1. What's the base on just log log? 10. So what should I put right here so that it equals 1? Also 10. This is kind of tricky right here. This doesn't happen a lot, but it happened here. All right, so we're going to condense these. Now, before I can condense all these, I also need to deal with this 3 in front. What can I do with that 3? I'm going to switch colors here just to show this. I'll write it in a new line. So I got log of 36, that's ready to be condensed, minus log of 9, that's ready to be condensed. In order for the next part to be condensed, I don't want the 3 to be in front anymore. So what can I do with it? Make it be the power on the 10. So this one is definitely a little bit more complicated than the other ones. It's about to get easier though. And remember, you get to use a calculator. So for this next part, we have a 36 on the top. Where does the 9 go? Since it's minus log 9, it's going to go on the denominator. And then the 10 cubed, what is that the same as? 1,000. That's going to go on top because it's plus. So you could actually technically do this without a calculator because 36 divided by 9, what is that? 4 times 1,000 is 4,000. So we have log of x equals log of, 4,000. So what does x equal? 4,000. There you go. We don't have to write an approximate because that's a whole number. All right, now I am going to spare you all the grisly, grim, gritty, gruesome details of how to do J exactly. We will not ask you for the exact on something. Did I say J? Goodness, I can tell it's the end of the week. Here for G, this approximate only. That's all we have to do. So this is a good one to go ahead and do in our calculator. We're not checking our work. This is actually how we're doing this problem. So we would do 5 caret, And if you don't have the updated version here, you're going to have to put parenthesis x minus 1. If you have the updated version, you get to just put x minus 1 up there. It does the exponent for you. And then x plus 2. I'm not even going to tell you why this is so gross, but this type of problem, very difficult to do by hand. All right. Always, I would start off with the zoom 6. Okay, while that's working, I'm just going to go ahead and write here what we did. Do you see those things intersected? So if you're not really quite sure where to look, just try it. Second trace 5, enter, enter, enter. And if you get an error, then you got to zoom out and try again, like the no sign change thing. So we're going to zoom out. I really don't know where to look, so I'm just going to zoom out, enter, and then I'm going to try again. And if that doesn't work, I'm going to zoom out and try again. As annoying as this is, I promise you it's easier than doing this one by hand. Okay, I will show you guys at the end of class what this by hand looks like. I'm just kind of asking you to trust me here for a minute. Oops, I changed my window. It's ugly. Let's see if it works. Oh, I'm zooming out still. Did y'all figure that out? Let's just see. Okay, second trace 5. I think I've zoomed out way too much. But I get an answer. This negative 16 point looks like it's going to round to 0.35. Okay, so we only have the approximate. If G had been 5 and over here had been 25, like if they had both been powers of 5, that's something we can do by hand. But because these are 5 and 7 really don't have anything to do with each other, that's a worse problem. Okay, H. This one's actually not too bad to do algebraically. Again, consider this to just be something simple like X. What would be the first thing you do? Add 10. So we're just using a lot of those good old algebra skills. Okay, again, consider the thing in parentheses to just be something simple. What next? Divide by 4. All right, this is an exponential. It's as simplified as we can go. What do we need to do now?
Numbers equal to each other.
I can't make 7 and 4 equal to be the same base. Is that what you're saying? I don't know. So, but that would be a great idea, but I can't do that. But can I rewrite it as a log? Mm-hmm. Log base 7 of 4 equals the exponent. We're just going to rewrite it as a log. I didn't do this on the previous problem because on the previous problem, both sides had an exponent. Okay? This one, only one side does. All right, we're still trying to get x by itself. So what would be the next step? How do we get x by itself? Hang with me here. Add 1. We have log base 7 of 4 plus 1 equals 2x. And the very last thing to get x by itself, divide by 2. So this right here is your exact answer. And if we want to get the approximate answer, we would just do, how do we do log base 7 of 4, by the way, in our calculator?
Log base 4 over log base 7.
Yeah, log of 4 divided by log of 7. Notice that I'm closing parentheses. Okay, and then I'm going to add 1. And you could do this all in the same step. I'm just kind of breaking it up. And then we divide that by 2. So 0.856. So as you can see on these harder problems, if all you have to do is the approximate, you may not want to do all this algebra and then type that in. You may want to just go straight for the y1, y2. You guys, with